Okay, so we're back and we're going to be talking about right triangle trigonometry. It's going to be a continuation from the last video that you saw. Okay? In the last video we kind of defined what sine and cosine theta are. Okay? If you remember from our right triangle we have the theta right here. This is the angle that you're looking at. It could be this angle if you want it as well. It could not be this angle though. We're going to talk more about that later, but this is mostly it's because this is the right angle. Okay? We already know the angle measurement of that. We can use this angle, and the opposite of this, of whatever angle you're looking at, this theta, is called the opposite side. Or I just wrote opposite. The adjacent side is the one that's right next to it that kind of makes up the angle that's not the hypotenuse. It's the one that's next to it. That's what adjacent means, next to. Now this theta right here, people go, well, how come this isn't the adjacent? How do we know this is the hypotenuse? The hypotenuse is always across from the 90-degree angle, every single time. If you guys remember that from geometry, the hypotenuse is always the longest side of the right triangle. And it's directly across from the right angle. Okay? So sine and cosine, if you missed the last video, you're going to might want to watch it and you'll figure out how we actually got these two equations right here based on the unit circle. I'm going to introduce the third major trigonometric function, which right here is tangent. It's basically just the ratio between sine theta, whoops, didn't mean to do that, sine theta and cosine theta. So if you divide these two by each other, you get what's called tangent theta. Now if you actually divide opposite over hypotenuse, so if I actually just drew this down real quick here, opposite over hypotenuse, that's the sine, and I divide it by the cosine right here, the adjacent over hypotenuse, you can actually simplify this equation a little bit where it's divided by hypotenuse, divided by hypotenuse again. You can actually cancel that out, so these hypotenuses cancel, and you end up with opposite over adjacent, which I wrote right here. Okay? So this is how to solve for each of these functions. This is how they're defined. Now, an easy way to remember these is called Sohcahtoa. Say it with me, Sohcahtoa. Now, Sohcahtoa just basically means sine theta is equal to opposite over hypotenuse, cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. So it kind of matches the functions. It's a good mnemonic to remember what each function how each function is defined. Okay? Now, before we move on, we're going to actually do a really quick example. You can follow along with me as I do it right now, or even better, pause it, try to work this problem out on your own, and then hit play after you solve it and see if you got the answer right. So if you want to do it that way, hit pause right now. Otherwise, I'm going to solve it right now. Okay, here we go. So we have theta equals pi over 6. The opposite side is equal to 5, and then we're looking for the hypotenuse and the adjacent side. So we're looking for the measurement of that. So to do that, what we need to do is figure out, well, which ones do we want to solve first for? Let's just say the hypotenuse, because it's in that order. Let's just kind of do hypotenuse first. So we need to find an equation that relates theta, the opposite side, and the hypotenuse. Those three things. So if we look over here, we should be able to easily tell which of these functions we should use, and it would be sine, because you have theta here, you have the opposite side, and you have the hypotenuse. The sine, the calculator is going to be doing this function for us. So we have the other three variables are involved in the problem we're trying to solve. So that's how we figure out which one we want to use. So we're going to use sine theta. So what I'm going to do is just basically recopy down the equation. Sine theta equals opposite over hypotenuse. Okay? From here I'm going to fill in what I know. So far what I know is theta, so I'm going to write sine pi over 6 equals opposite, we know opposite's 5, divided by hypotenuse. Okay? From here you can simplify this sine pi over 6 using a calculator. Now when you use a calculator, make sure you're in radians mode, because this is in radians right here, not degrees. If it's in degrees, make sure you're in degree mode. So you turn it on, and there's a button at the top if you're using this one, and it says DRG. So you hit that button, and then it says degrees, radians, and grade. Well, we want radians, so I'm going to enter on the radians, and then it'll say a little rad on the bottom. If you need help with this on your particular calculator, let me know in class. No big deal. All right, so I'm going to do sine of pi over 6. So sine of pi over 6 is equal to 0.5. So I'm going to write 0.5 in here. Now, here, I want to get rid of this hypotenuse, so I'm going to multiply both sides by, well, actually, let's just do that the next step. So equals 5 over hypotenuse. Okay, now I want to get rid of this hypotenuse right here, so I'm going to multiply it by hypotenuse on both sides. Okay, hypotenuses cancel right here, and you're left with 0.5 times hypotenuse equals 5. Now to solve this, I need to get rid of this 0.5. Okay, since I'm multiplying, I need to divide, so I'm going to divide by 0.5. 0.5 cancels. When I do to one side, I have to do the other. Equal rights in math. And you end up with the hypotenuse being equal to 10. Okay? So the opposite here is 5, and the hypotenuse is 10. Now we're looking for the adjacent. Now you can do this two different ways. One way is you can use Pythagorean theorem. You know that this side squared plus this side squared has to equal this side squared. So if you want to use Pythagorean theorem, you can do that. Or if you want, you can use trig. Either way, you'll get the same answer, and that's the beauty of trigonometry. It just ties right back together to the geometry that we learned before. So why don't we use the trig just as extra practice? So we're going to find the adjacent side now. So what I would do is hit pause and try to figure this out, unless you did it already. And then once you figure it out, hit play and then check if you did it. So pause. Okay, so let me give myself some room here. This time I'm going to use cosine theta equals adjacent over hypotenuse. Okay? Because this ties together the theta, adjacent, and the hypotenuse, which we know right here. Okay? From there, I'm going to fill in the angle measurement, which is pi over 6, equals the adjacent divided by, now this time our hypotenuse is 10, so I'm going to put a 10 in here. Okay, we're going to need our calculator again, so we're going to do this time cosine of pi over 6, so I'm going to cosine pi over 6, and I end up with 0.866, so I'm just going to write 0.87 to round, equals adjacent over 10. Now, to solve for adjacent, since you're divided by 10, we've got to get rid of it, so we're going to multiply both sides by 10. That's a multiply. 10's cancel here, and you end up with about 8.7 equals the adjacent. So hopefully that helps you understand how to use trig to find angle or to find side measurements given the angle. So if you have any questions about this, let me know. We're going to do some more practice problems in class. All right.